This is video file 2 for Chris Bailey. Now I wanted to speak briefly about the roof and about roof triangulation, because I remember from one of our discussions you mentioned that you were thinking about creating a cathedral ceiling in the property. I think it was because of the limited head height. I know you were thinking about it, whether you're going ahead with it or not, I'm not sure. So just in case you do go ahead with it, I just want to discuss some of the potential issues that may arise. Like say, if you were to create a cathedral ceiling, so it would involve removing this horizontal ceiling joist here. So if you remove or cut this horizontal ceiling joist here, one of the consequences of that is it will put an outward pressure on the walls, or an outward thrust on the external walls here and here. See, I suppose as long as you have a timber, effectively like a timber triangle here, this is a timber triangle here all the way around. As long as you have a triangle and the timbers are fixed to each other here and here and here, a triangle is an inherently stable shape. And if you have that triangle and you've got this tie here, you won't put any lateral load on the wall. There will only be a vertical load on the wall. But if this tie is removed, what happens then is that will basically put an outward pressure on the walls. And what can happen is the walls over time, now this won't happen quickly, it generally happens over many years, and you'll just get a very slow movement of the walls. The walls will go out of plumb. Even with walls that are, you know, as thick as yours, like your front wall, your south facing front wall is quite thick. But even with thick walls like that, slowly over time, horizontal pressure can make the wall to lean. And then on the rear wall, your rear wall is much thinner. It's probably only 250 mil because it's a hollow block wall. You know, that wall would be prone to moving even more so from horizontal thrust. So if you want to create a cathedral ceiling, you can still do it, but there are certain things you would need to do in order to make sure that you don't put pressure on the walls. So let's say, for example, just have a look at what happens here. When you remove this joist, the walls move out. But also what happens is the ridge here, you can see the ridge has to kind of drop. It has to lower. In order for the walls to move out, the ridge has to drop. You'll see it again on the next page here. Basically, there's another joist or another situation. Now this is timber frame here. This is a timber frame example, but it's still relevant in our case, even though we have a stone wall. What happens is you remove this ceiling joist. That puts an outward pressure on the walls, and then the wall moves out and the top ridge moves down. So if you want to remove the joist, one way of helping to prevent the creation of horizontal thrust on the wall is basically, if you prevent the ridge here, if you prevent the ridge from dropping, if you prevent the ridge from sagging, if you prevent the ridge from dropping from this location to this location by the addition of a steel beam, then the roof can't move. And if it can't move down, it effectively can't put a horizontal load on the wall. So the example here, it's not a great photograph, but this is an example here of where it's been done. Basically, that's a steel beam there, and a steel beam has been added in, spanning from gable, that's the gable wall, spanning from the gable wall to another gable wall. And that steel beam is used to support the timbers. That stops, this steel beam is very stiff, much stiffer than the timber. That steel beam stops the ridge from dropping. And when it stops the ridge from dropping, that prevents a horizontal load from being generated on the external walls. So this is one way of dealing with it. Now, in our particular instance in Treannadullagh, we can't put a steel beam right at the ridge, right at the top, because it would need to span into the chimney. And you're not supposed to span beams into the chimney. You're definitely not supposed to span timber beams into a chimney stack for fire regulations. But you're not really supposed to do it. It's not a good idea to span steel into it either. Because, you know, steel beams can get soft if they get hot. So in your particular instance, instead of adding a beam right at the ridge, what I would propose to do is to add 2 beams on either side of the chimney. So your steel beam that you're adding in would be spanning from this gable wall to the internal gable wall to the end gable wall. And now we would need 2 of these ones. So basically that's the one on the south elevation. You would also have a similar one. So that's the one here. You would also have a similar one on this elevation, mirrored across at the same location on the other side here. And that's how you would support the roof if you wanted to do a cathedral ceiling. So if you look onto the next page, this is an example of, now in this particular example here, there is actually the ceiling joist was moved from this location here, and it was moved up to this location here. Now it is possible to remove the joists altogether, but in this example you've actually got just a higher ceiling joist. So it depends on what you want to do. So this is typically in this drawing here. There's 2 areas where, you know, the steel could have been positioned. So he'd either place his steel beams in here, just above the joist here or here, or you could put the steel beams underneath the joist. The problem here is that they'll be exposed. This problem here is that they'll be exposed. But either or, you don't need 4 steel beams, obviously, you only need the 2. So you could put them in here, you could put them here. Now, the problem, I suppose, the problem with what we're doing here is, if you put in, let's say, if you put in your 2 steel beams here to create your cathedral ceiling, what you're effectively doing is a lot of the roof load that was going on to this wall here is now going on to the gable walls. So we've increased the amount of load that has gone on to the gable wall. And now that might cause a problem, as I'll go on to discuss now, because while I would say that the walls of this property are generally sound and can be retained, there are some issues with this gable wall here. The east gable wall, it's out of plumb, it's leaning out of plumb, and it's also got a bulge here. So there has been some historic movement. So we need to be mindful of what we do here. If we decide to do a cathedral ceiling and put in these steel beams, you know, what we might decide to do, or what you might decide to do, is to put on a lightweight roof, for example, possibly even a sheet metal roof, you know, to reduce the amount of extra load, because adding additional load onto a wall that's already moved, probably not a good idea. Otherwise you might decide, well, we'll knock the wall and rebuild it. So I'll just go on and discuss what I see with this east gable wall here. So I set up 2 plumb bobs on the east gable wall. This is the 1 plumb bob here from the very top, and then I set another one here. Now, measuring the amount of deflection, that's it there. You can just see that was the maximum amount of deflection or deviation from vertical is 170 millimeters. So the deviation from vertical is 170 millimeters. This wall has effectively moved out by 170 millimeters. And just to give you an idea, the guidance that most engineers will follow is we have a rule for stability which is called the 1/3 rule, which states that if the center of gravity of a wall, the center of gravity here is the area shown shaded. If the center of gravity here is within the middle third of a wall, then it's fine, it's stable. But if it's not, if it's outside, then it's unstable. So this is an example of an unstable condition here. The center of gravity of the wall of the there's the center of gravity. The middle third there is the that's the center of gravity. There's the middle third shown. But when you draw a straight plumb line down from the center of gravity, you can see that the wall is outside of its middle third. If we go back here, it's inside of its middle third, and this is an example here where it's just borderline. So in this example here, it would be sound. In this example here, it possibly might be the best thing to do, might be to knock it down and rebuild it. And in this example here, I suppose there are more options available. So when I drew out your, like this is a scale drawing of your wall, basically, and you can see your middle third there, that's your wall is basically at the minute it's borderline. So if it had gone much further, I suppose I might be saying, well, maybe we should knock it down. But at the minute, if you want to retain it, it could be retained. So I'll say if you want to retain it, it could be retained. So you can see the other problem with this wall, as well as a lean, as well as being out of plumb, there's also a bulge here, a local bulge here at the wall. You can just about see it in the photograph, but it's very difficult to see these things on a two-dimensional photograph. You really need to see it on site. The bulge is located here. Now, the one thing I will point out with this bulge is, I'll talk about what might cause it in a minute, but there's no cracking. There's a cement render. As I said, a cement render has been used on this building, and cement renders are brittle finish. So if the bulge had occurred after the cement render was put on, there would be cracks in the render. I would see cracks in the render. But at the minute, the render looks pretty good. There's no cracking associated with this bulge in the render. So I come to the conclusion that the bulge that I see in this wall is historic. And, you know, possibly there have been some repairs done to stabilize the wall in its condition. But the bulge is not, the movement has not been recent, it's been historic. So for that reason, I would say, well, we could still retain the wall. If we want to retain the wall, we could retain the wall. It's borderline from a kind of stability point of view. From the bulge point of view, it's another problem. But I would say we could still retain the wall. The only problem, I suppose, then is that we're actually increasing the load. If we put in a cathedral ceiling and we put in a beam here and a beam here, we're increasing the load on this wall. So there's an element of risk involved. So for that reason, I would say it might be best to use a lightweight roof. If you were thinking of using a heavier roof, you know, then we might consider rebuilding this wall and building it up again, depending on what you were doing. Now, this is how a bulge forms. You see, this is basically stone walls, the way stone walls were constructed back in the day. So there's no cavity, it's a solid stone wall. The stones were cut and shaped, and there was the good face was put on the outside here, and then they have another good face on the inside here. Now this stonework looks very tidy. It's often not this tidy. Often in here in the core, the stones are quite jagged, and it's just filled with rubble, like what you say, a rubble-filled core. And you effectively have two leaves. Now sometimes there can be through stones, and the through stones will help tie the two walls together so that you don't get bulging. But oftentimes there were no through stones, or the through stone may have cracked, something may have happened, and a bulge has formed, like this. And in an extreme case, what can happen is, that's the bulge there, you can see there's a cavity created. And, you know, I suppose I would be slightly worried in your case that a cavity has been created here, because the bulge is visible externally, but there's no bulge visible internally. So it's not as if the whole wall has, it's like this condition here where we have a bulge externally and no bulge internally. So you'd be a little bit worried that, you know, a cavity has formed here, possibly. Now, this is not relevant in your case, I suppose, because I don't think it's gotten to a stage where we need to do any work with this in your condition, because, as I say, the cement render has not cracked. So I think the movement is historic. But if we did at some stage decide to do something about it, this is normally the way you would do it. You would add what's called a patras plate. And this is a patras plate which would go on the inside and the outside, and there may be a steel beam going through it. This is traditionally the way they've dealt with bulges in walls, with patras plates. This is just a typical detail of a patras plate here going through a wall. Again, it's not really, we're not going to do it in your case. I don't think it's necessary, but I just wanted to show you what, what is often done with bulges. These are typical examples of traditional patras plates here. And this is just another example of a more modern way of dealing with a bulge in a wall. What they will do is they will drill a hole and grout in a steel bar. Now the steel has to be stainless steel, high-grade stainless steel, because you can't have it corroding. So they drill in a stainless steel bar, and then basically it's grout filled. Now, because there may be a void, oftentimes there's a void in here. A void has been created by the movement of the bulge. So this core fill can often have a void. So because of that, what they do is they don't just grout it in. They don't just pump it full of grout. What they do is they have a kind of a sleeve here. It's like a polyester sleeve or a sock. And they fill the grout into this sock. And this sock prevents the grout from being lost if there's a cavity there. And what it does is it ties this wall and this wall together. And in this example here, there's no patras plate. Basically, it's hidden. You know, you often wouldn't see this kind of a repair detail, particularly if you want to hide it. So that's another way of dealing with a bulge. But as I say, in your particular case, I don't think we need to do these things because I think the movement is historic, and if it's not an active movement, then we might just leave well enough alone and just keep an eye on it and watch it. And if at a later stage we notice movement, let's say if you were to increase the load on the wall and then you notice cracking or you notice movement or there's something you're concerned about, then at that stage you might say, okay, well let's maybe do something like this to prevent any future movement. And the other thing I was going to point out was there's many areas in your stone. If you do decide to remove the cement render, there are many areas where it's necessary to do some regrouting. And sometimes when you do regrouting, what you do is you need to prop the wall. Particularly if you do large sections of regrouting at the one time, you might need to prop the wall. But propping like this is not necessary if you do small patches at a time. Just do a small patch, rake out the loose mortar back to about 50 mil, 30 to 50 mil, 50 mil we'd say, and then repoint it. And I have some good videos showing how to do that in areas where regrouting may be necessary. And there's probably going to be some areas where it's going to be necessary in your building. So that's the way you would prop it. But generally, if you do regrouting in patches, you're not going to need to prop the wall. Okay, I'm going to stop this video here, and I'll continue on video 3, talking about the rear wall. Okay.